Hello, everybody. Welcome back to your favorite YouTube channel about Kotlin. And my name is Anton. I'm a developer advocate in Kotlin team. And today with me, I have Uberto. Hello, Uberto.
Hello, Anton. Very
Hello.
nice to be here.
Nice to have you. And we are separated like kilometers, thousands of kilometers apart. Uberto is in Japan. I'm in Estonia. Folks who are following us in the chat, feel free to say where are you from. So we have folks joining on the stream. Today we are going to talk about a very nice topic, actually, about functional programming with Kotlin and especially having fun with Kotlin in functional programming. So I know, Berto, you are an author of a book on this topic, right?
Yeah. It's been I have a book here.
Yeah, I'm following Berto on
Yeah.
Twitter, and he talks about functional programming all the time. So I thought, why not to invite him for a chat, and he will explain what's so fun about it. So, Berto, I will not take a lot of time from you. I think we have a lot of content to talk about today, and the floor is yours.
Thank you very much, Anton. So let's start without further ado. And this talk it started with this meme that you can see about functional programmers. And it's not about, of course, being more intelligent or whatever, but just when you start doing functional programming, you start using simple function, and then you learn all these complicated, powerful techniques like functor, monads, and so and so. But and you kind of start, you fall in love with them, and you start overusing, the golden hammer pattern. But when you got more experience, you start realizing that actually the more important thing is still that try to use a simple function, make things as much as simple as possible, and also having fun with that because yeah, if it work well, you have fun, and if it you have fun, it's also become a joy to work. So this is today talk about. So let's also please, Anton, please stop me anytime, or if you wanted to clarify something if I'm not being clear, or also if there was some interesting question on the forum. But we also have a time later to in the conclusion to talk about the whole topic.
I will be following the chat, folks. So if you have any questions, I will try to do my best to interrupt Uberto if it's relevant for the specific moment.
Yeah, if you manage. But before, let's just last year has been a year very important for me, and the first reason was that I moved to Japan, and we bought a very old Japanese traditional house, and we started renovating. But the reason that is more relevant to this talk is that I finished my book finally after 4 years with the COVID in the middle, so it's been a longer journey. But writing this book has been very important for me because it was really the first book where I really put my own consideration, not just a manual, but some original content. And it's also a book that it changes, when you write something, you teach something, you learn. It's the best way to learn. And I started the book where I was still probably in the middle of that meme that I showed before, when I was still kind of in love of very complicated theoretic stuff about functional programming. I mean, I love functional, category theory and other things like that, but it's definitely not needed to be a functional programmer. And but rather to the end of the book, I was actually started to appreciate the simplicity and how using simple function can really simplify our job. And we should aim to keep things as simple as possible and leave the complicated step when we actually need them. It's not that they are bad for set, but they're just not not good for everything. And so in this talk, we talk about how to do functional programming and why we should do functional programming. But let's start a bit about what's the goal. And the goal at the end is that we have a big problem, which is in our case is writing a program that solves an actual problem from the user, from the stakeholders. And to solve this big problem, we wanted to break in a smaller problem. And we have several strategies. The first strategy is kind of using called procedural programming. And basically, we write our code as a list of commands. And each command works on the global state, modifying the state of. And if you think about that, this is exactly how you do stuff like in BASIC or PHP. I mean, you can also do different, but a small script, this is a really great way of working because the global state is still relatively small, so it's very super fast and very convenient. So I'm not anything against procedural programming, so far that we are using in a kind of limited scope of project. Because after a while, it became very complicated if we have too much global state to think about. And that's the second paradigm, which is the object-oriented programming. And the idea of the object-oriented programming is to keep, instead of using commands on a global state, try to keep the commands coupled to a state that is local and is hidden from the outside. So you don't have to think about the state of the other object or the whole application, but just to a simple, atom of state, which is each object. And the object can communicate to each other and they collaborate to solve a task. Now, the approach of functional programming instead is different because in functional programming, the idea is keep the state immutable and just apply some transformation. And just to have a bit of more context, let's look at there is an interesting answer on Quora by Alan Key, which is the father of object-oriented programming, which I really recommend you to read Alan Key answer on Quora if you wanted to understand better the genesis of object-oriented programming. But for the talk today, what is relevant is that he was thinking about object a bit like a computer in a network, or even like a biological structure that exchange signal, they communicate to each other and they collaborate to do some task. So this idea of having this a lot of small things around that talk with each other, and each one has its own mutable state inside, which is a great way to work. I work with functional object-oriented programming for many years, and I, for some kind of problem, I think, is still the best way, best approach at all. The functional programming approach instead is quite different. And here you explain why it matters. But especially what is functional programming? At the end, it's just something that a way to write a program just using functions. So we use a function like combine together to write that became bigger functions, and each function just take the program input and deliver a program output. So all the mutable state is kind of external to this function, and then of course there is a lot of techniques, let's say, to handle this global state. But the core of our program will be just handle immutable state and simple transformation. And when we are talking about function, we tend, to think about the function in programming is like a method of an object, is something that do something else. But if we took a bit of the functional programming hat, we need a bit more mathematical point of view. And we need to consider the function as a transformation. So for example, if we have a function from a string to int, we can consider a transformation that something that transforms a string to an integer, or another function that take an integer and transform a string. And of course, there are almost infinite number of functions that can do that. And if you ask probably write a function that transform an integer in string, you will write something like integer to string, or the opposite, passing a string in an integer. But actually, there are so many, and here just I did this silly bar function that just repeat the string bar as many times that you specify, or a quite useful function that just return the length of a string. But there are so many ways that we can transform a type in another type. And this is the kind of the idea of having this transformation. And probably the simplest transformation where everybody probably in a modern language know about functional programming is the map on a collection. And I put also the Java code just to have a bit of reference if people are not everybody knows about Kotlin. Kotlin has a nice syntax, but here the idea is that you have a list of integer, int list, and you want to transform in a list of string using a specific function, in this case our BA function, our bar function. And we just apply, or we map the function over the collection. And this is very different from using the for loop that it's typical of imperative programming, where we have to specify with a temporal variable and we do something. This is much more declarative. We just say how we wanted to transform the collection. And this is also a kind of interesting point of functional programming, where people start struggling usually, because in functional programming, functions are not only something that transform code, but they are also part of data. So you can create a function like this compose that take a two function as a parameter, as input, and return a new function as output. So functions can also work on other functions. This is called IR order function, but it's not that important. What is interesting is that applying this function composition and transformation, we can do a lot of things without actually writing the code itself. I mean, just composing the function together, rather than re-explain what we are going to do. And we see, if this is not very clear, we will see some example. Also note that in Compose, we have this F1, F2, but when we apply, I mean, since F1 take the first parameter and F2 take the second parameter, we need first the F1 is nested inside F2. And this is, a bit hard to read. So there was also this tweet from my friend Dimitri that was, we had a lot of discussion with Dimitri about this stuff. And basically, what is the best? He was discussing what is the best way to read. I mean, the most readable way to write this stuff. Here we have pre-function, and we started with the number, and then we needed to apply foo, and then bar, and then quicks. In the nested way, it's okay, but using the let in Kotlin, we can also specify in chain way, let's say chainy way, where we basically apply on the order that then I mean you write in the way that you apply. So first you write the first function that you apply, and then the second, and then the third. Now the question is, which is more readable? I personally prefer the second one because it's kind of more evident, immediately evident what is first. But there is definitely not anything wrong with the first one. I mean, if some people find the nested syntax more evident, then that's totally fine.
I can
Probably.
even add
Yeah.
one thing.
Yeah.
There is an opinion. I think Roman Yelizarov was the author of this opinion, is that if you have two options how to write the same functionality, you should prefer the one that is shorter. In this case, the first example is shorter, and it kind of goes against this idea that chaining should be not a good word, should be, is preferable with this style. So there is always like a trade-off. Which one should you prefer?
That's I mean, I'm not that convinced that is a very good heuristic choosing the one that is shorter. I mean, of course, if one was like a 50 line and the other was 2 lines, of course. But counting the single characters, I'm not totally sure. But I mean, it's a good point. By the way, if it's in this specific example, we can also use Kotlin receiver formula and just having for.bar.quicks and stuff like that. That's also another alternative, which is kind of less flexible because it doesn't work with the modern parameter, at least for but it's another thing to keep.
There is one question in the chat about this. If the performance is the same between those two, like, does it compile to the same bytecode? In my opinion, it doesn't compile to the same bytecode. Like if you just look at this way, but you have to check the implementations of those scope functions, and most likely they are inline functions. I just
they're definitely
they should be, and
then
it should be the same bytecode, I think.
No, I mean, I think the bytecode will be slightly different, but when the hotspot compiler kicks in, it should be optimizing more or less in the same way. So I would be surprised if there is any difference in performance.
Yeah. Like performance engineers say that predicting performance by bytecode is not really the way to go. You should actually measure it.
So you need to measure, because also, I mean, the bytecode got really changed a lot by the hotspot compiler when after 10 times 10,000 times the dirty ones, it got optimized in a very surprising way. Yeah, if you have a problem performance, please benchmark it very well. But for casual things, it definitely doesn't matter. I mean, if we are not talking a super optimization point, there is really no difference. And this is something. But let's start coding with our nice IDE.
Mm-hmm.
And let's see. And okay, so first let's just to show this idea. Basically, this is just for people. This is just a Scratch file, so we can have something like that. And this idea is that if I do int list and I wanted to map to well, let's say to bar. Yeah, it's this one. So basically, it's blah 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 blah. But if I wanted to apply this also to the string line, I should do like string line bar, and hopefully, yeah. And now this is just of course it's a bit silly, but just basically multiply by 2, but just to show the alternative way. I mean, we can just to explain. We can call like bar line. We can compose bar, yeah. And basically we create a new function, and then we can do int list map button, and we can say that is hopefully the same result as before. And this is a way to create a function which is probably not familiar with most of the developer, and I don't say that is super important, but sometimes it's convenient. And the good thing is using something like that is that if we are already kind of confident of BR and the standard function, we can get a new function basically without writing any code and without introducing any bugs, hopefully. But what I really care now is that this idea that in functional programming we compose function, which is something that a lot of people are not familiar with, and a bit, seems a bit super complicated way to do things, but it's probably just things that is familiar or not familiar, because after a while it became kind of natural, as you can use, compose integer, you can also compose function. And I wanted to also introduce another, a bit of a playful way. Basically, let's say that we have a function that takes 2 parameters. And so this is get the user from database, and we just say database connection string, but it's not important. So for this example, we just return how to code the user. But basically, this idea that we have a function that takes 2 parameters. But in our code, the connection string to the database will be very far from the point where we actually have the user ID, because one will be in the infrastructure layer, the other will be in the core. And so it can be a bit inconvenient to bring the connection up to the point where we actually have the user ID. So what we can do, we can transform a function with the 2 parameter in a kind of a 2-stage function where we apply 1 parameter separated by applying the second one. And so we can do this in a kind of a generic way. So we can create a function that is called partial apply, that basically this function will take a new function as a parameter. And let's say that is a function that takes A and B. Also, note that Kotlin has this very nice syntax where you can specify the type of a function just using arrows, which I really like. And then we put some generics here. And then we have the first parameter. So in this case, will be A. So if we take the function with the 2 parameter and we add the first parameter, we basically return a new function that take the second parameter and give us the result that we were expecting. And the implementation is actually quite simple, because you just need to create a new function that take a parameter of type B. So let's be super explicit. And then at this point here, we already have A and we have a B, so we can actually call A and B. And just to show how to use, I can just say, let's call a user fetch. My partial application of get user with a specific database. And then I can call user fetcher with a specific number. And hopefully with yeah, it will return the user with the ID 7. So this is another example of how we can apply, how we can play, let's say, with the function. And I don't know, but I really find this stuff actually a lot of fun, and trying to figure out which type goes with which other type, how to combine function is something that I love, and keep things kind of simple.
I think this is a good place for a question here. We had one question from a chat. It's actually about Java. Can you do the same with Java? And in one of the slides, you actually have showed the signatures, how they look in Java and Kotlin. So technically, it is possible, right, to do the same stuff.
It's definitely possible, and there's a scratch Java somewhere. Okay. I don't have it. I mean, it's definitely possible, but it's just a bit more verbose, because you needed to put this
I think if you go to the definition of map, you will see.
Yeah. Well,
Yeah.
but I mean, it's something that you need a function. See, I'm really not used to use. Yeah, then you need the partial apply. But it's definitely the same. It's just that, and then you need a function.
Well,
Function two, I think, is something like
my
that.
answer would be that if because Java doesn't have this top level functions, and you need to have a functional interface that models the function like on the top level, and you need to put those types into the signatures, uh, like to express the higher order capabilities of the functions in Java, then it becomes a bit more verbose, like
Yeah, no,
bulkier, longer signatures, and so on.
exactly. It became vulnerable, and also I don't remember, for example, if this was called a function two or b function or something like that. I mean, there is the name change, and this is definitely function, and this is probably no, this is not probably is function. B function. Yes, it's the function. But yeah, I mean, it's still and then you needed to create a new function that I don't remember exactly how to create a new function in Java. But yeah, so something like that is definitely but I wanted to show something so that something that you cannot do in Java actually, that there is a way to do function partial apply that is really specific. I mean, I like, and this kind of idiomatic Kotlin. And the trick is that in Kotlin you can have a class. Let's say that since we are doing a database, let's call database one. And you can say that this class inherit a function, inherit from a function, and in this case will inherit from a function of a type from A to B. And then of course here we wanted to give the database, because the database, and also we need the function to apply to the database. And this will be a function that let's say that we have database, which is a string here, but of course, and then something and then this will be a no, yeah, yeah. Yeah, and this will be yeah. So basically, this is the same thing that, but using a class, and our class implement. I mean, inherit. Implement the function. So of course we needed to do the actual implementation. Let's call it this ID, for example. Or we can call it a something more, and then we can just say and exactly as we did before, we can define user factor as a DB runner. In this case, we have a class that actually implement an interface, and we can use this class anytime that we need a function. And yeah, you can see here that we have the new user. And this is something that I actually use. I mean, not sure, but I use it in a lot of places in my code because it's much simple and convenient to use, especially if you have more than one fixed parameter. Does it make sense?
Totally.
And this is something that you cannot do in Java. I don't think you can. Maybe you can, but it will be much more verbose and complicated. In Kotlin, it's really concise. But okay, let's go to the main stuff of today. And okay, so we have a super small application done with the usual object-oriented pattern to make a web application, which is a model view controller. And if you know the pattern more or less, you have this controller that have this service with the model of our application and another object that know how to handle the view of the application. And the controller will contact this two and make sure that you can basically produce the web page according to the request. So in this small application is using Ktor as a web server framework. So basically we insert some data, which don't care, and then we define the root of our HTTP, and then we start the server. Now the interesting part is in this root. And well, it's still very small, but basically we are using the controller in, for example, this is just the resources. This is the root that has just some static content. But then if we ask the user, we go to the controller and tell the controller, okay, respond with all the users. So the controller will require the user from the server. Then we'll create a response with the user page calling the view, and then we'll pass this response to the application call. And more or less, this is the same fix with the other page that return the user ID. And just to show that I'm not cheating. This is a mini application user list. Click on the user, have a user data. Nothing fancy, but I mean it's working. Just to say. And that's it. And this is the object-oriented style. So we'll try now to write to transform this in a functional way. And the first thing that we do, we start off with the one root, and basically what we want to do. Let's define a bit what we want. Is having something that a function that from the request extract the user ID. Let's say the ID. Another function that from the ID will get the user from a database. Another function that from the user will get the HTML. And finally, a function that from the HTML will get the HTTP content, the HTTP responses. So to do this, first we need to, we wanted to refactor the code, so we can, of course, copy paste the code that it's here. So let's start writing this one. And we can extract this stuff like get ID. And this, let's but I want to pass a call parameter. And in this way, I can get the ID, which is internal, so it can be nullable, just to make sure that this will be nullable. Then I need another function from the ID to get the user. And we can see here that this is here. So it's something that the user service is doing. And user service is using this transaction. So let's start putting the function outside the object. But this transaction basically is getting a kind of a database using some local thread variable and stuff like that. So something that is not explicit, so it's not functional in this way, because we really try to make everything explicit, everything that needed to be in the input from the output. So let's make the database explicit, and so this is by the way, expose library. Sorry, we get the transaction now. It's operating on the database and it's returning the user. So if we go back to our main, so we can just use get user by ID and pass the database and the ID. And this will return our user. Now we don't have the database here, but here when we created the database, we actually have the database. So we can return this database and also refactoring everything to be more explicit. And this will be database connector and the next operation. So it's basically creating the schema for the user. We will put in also something that we want. It will be executed, but it won't affect the final result. And also, let's put it the database explicit also here, just to make double sure. So if we go back to the main, at this point we can get the database, and from here we can get the database. Now we needed the database here, but this is here. If we want, we can pass the database here and so on. So, but if you remember, we just saw how to do this kind of stuff in our first example. We can use this database runner, small class, and we needed to change it a bit. But this will allow us to basically put using the database and our get user by ID function to create a new function that doesn't need the database again. So let's just put it here just for the moment. DB runner. So this now this will be a real database. And this will be also clearly the database here. And so this DB runner now is a class that take a database and then will run any function that take a database as a parameter. So we can create our, instead of having this controller stuff, we start creating our small function, user fetch, let's say. It's called DB runner.
DB runner, yes.
Yeah, I'm kind of terrible with and then we pass the get user by. And okay, at this point we need to pass this let's say user fetch. We need to pass it here, but that is just a function that goes from an integer to a user.
There is a question in the chat. Maybe you can clarify. Alejandro is asking why are you using the user service and the user view as classes and not objects? Maybe it's just confusing.
No, they are object. They are object.
Yeah, they are objects. So
yeah,
they are instances.
Yeah, they are all instances. There is no classes. No, not sure what it meant exactly, but they are not used as a static class. They are all instances. Of course, I mean there is many style of object oriented, so but this is, I think, quite typical. Now to continue, basically here we have a ID that can be nullable, but for the user fetch ID needed to be not nullable. So we can change this to use the let function, because let function will make sure that it's only called by with a question mark when the ID is not nullable. So here, this is not nullable ID, so it can work here. And of course, if I did null, this rest will be null.
Okay, there is a clarification to that question actually, and they were thinking not about the object instances, but about the object keyword. Why not?
Why not to put this as an object keyword? Why? Yes, absolutely. I mean, you can put, but I don't think. Well, if it's an object keyword, everything became an object. Yeah, I mean, you can do that. It's still perfectly object oriented, but then it became, using object means that it becomes harder to test things because, you cannot create a controller that doesn't use the database or stuff like that because everything
becomes coupled.
becomes coupled. But from the point of this exercise will be absolutely identical because you start from this and you will do exactly the same refactoring. But
Right.
we try to be as much decoupled as possible rather than be coupled. So we really want to make it. And so the third part is to transform the user in HTML. And even if we look here, we see that this is calling this function. So let's go to this function and do more or less the same thing that we did before. So let's extract. In this case, it's kind of simple because there is no much global state. Of course, in a real application, this could maybe need more parameters and other kind of refactoring, but it's always possible, to extract. And we wanted this everything to be a function. So what we can do use a page of REST, and this is just and we have the same problem than before, that user can be nullable, but REST is not. So let's do another .let. Let's see, user page. Yeah. Oh, we can. And now this is we can see here. So this is this signature, which is just how Ktor wanted the result to be. And we needed to convert this result in HTTP response. And again, if we look at this code, we see that we need something like this. So let's continue with this pattern. And and that's it. And this now is HTML. And we can finally call the respond and pass in the rest. But there is still another issue, which is okay, what if there is an error or anything else that goes bad and this is null? So let's see how we were doing here. Okay, so there was also this one with this one with the not found error page. Okay, and then let's do this copy paste to put in external. Going back here to the main, and just let's put and just let's put the HTML content. So in this case, now response is always an HTML content. So in one case, it's the successful response. In other cases, not successful. We respond with this. We can remove this one, and we can verify that this is actually still working. But yes, of course, we needed to pass the fetch here. Yeah, and then of course there is always something that yes. So this needed to be from int to a user because fair enough, I mean, user cannot be present in the database. And the application works as it was working before. So no changes.
Mm-hmm. But
and
what
yeah,
what did we gain with that? Like at the end, we have transformed, like you had on the slides and the tweet by
yes,
Dmitry, right? We had this nesting of function calls, and now we have this pipeline that is composed using scope functions.
Yes, and we can even put a bit more like reference and stuff like that. Yeah, what do we gain? I think we gain the ability to have this smaller function. I mean, the logic split in smaller function, which are easy to understand because they don't have a complex object. They really have everything that take one parameter return another parameter. So it's easier to understand how this stuff works. And but of course, I mean, it's always debatable. I think it's easier to test, and let's look at later on the conclusion. Basically, yeah, there was a bit of a consideration when this is a good style or it's not style. Okay, I saw that we are already quite quite late.
We are not so restricted with timing, but we can go a bit over time. It's fine as soon as as long as people are watching us and are interested. So, folks, thank you for staying with us on the stream and watching us coding.
Yeah, the next step that I wanted to show basically was because now we have a problem that the only error that we handle is the not find error, but of course there could be other things that goes wrong. So ideally, I wanted to basically handle the result in a kind of functional way, and just to give you this example, this idea of use a seal interface with our result, but because the result is also used by Kotlin, I prefer to call it outcome. And this outcome basically is an outcome of some kind. So basically, we have an outcome of some T that have two possible data classes that implemented. One is a success, and of course the success of T, we have a value which is actually the successful value, and this is a returning outcome of T. And the other possibility is having a failure, which maybe have some kind of error message. Let's say just keep it simple as a string. And it's also implementing outcome of T. But at this point we don't have T, so okay, no worry. We can use nothing. And if we want to use nothing, we needed to declare T as an out, just to make sure. But in this way, basically, we can have this type that wrap around the two possible cases, success or failure. So we can now get our function, and instead of returning a nullable, we return an outcome of it. And at this point here, we can, well, depending if int is null or not, we can do something. We can do cleaner stuff, but just to make sure, if it's not null, we return a success. Otherwise, we return a failure with something like ID not something like that. And now came we need to do the same with the fetcher. Instead of returning a user, we return an outcome of a user. And this means that our user fetcher this also need to return outcome of a user. And we can do something. Because here, being a database transaction can also fail for a lot of other things. So let's handle first the success case. So this is the failure where basically there is no user with that user not
wouldn't
found.
you use the result type from the standard library for the same?
There is a limit. I mean, there are several limitations with the one from the standard library. One is that we cannot define our own errors. Everything must be an exceptions. But here we should create an exception, for example, just to communicate that there is no user. And also we want to do some finesse that is a bit, I mean, but yeah, I would be great if there was a more flexible result in the standard library. The other thing that we want is that there could be a general error on the database. So we want also to do a kind of a try catch exception. And then in this case, we return something like a failure with the database with something like that.
Mm-hmm.
And so we just remove this one. Yeah. And basically, now we wanted to do something like, okay, so we don't need the question mark anymore, but we okay, let's convert it to, I mean, it is an outcome, so we should do something like when it, and then separate the two cases, but that will be super complicated. I mean, super variables. what we wanted to do instead is that, okay, this is an outcome of integer. This is a function that take an integer and return a user. So we want to transform one int to, want to transform an outcome of integer in an outcome of user. And so this will return an outcome of integer, and the fetcher will return an outcome of user. So we can define in our outcome some methods, and just so basically, if we have a transformation, this is basically just a normal generic. So if we have a transformation from T to U, we can return an outcome of U. And the code here is relatively simple because we just we are inside, so we can decide what to do in our case. The first, because this is a silk class, it came quite naturally. If it's a failure, we can just return the failure. It's not a problem. If it's a success, we can instead create a new success, taking the value and applying the value to the function. So we get the value from our success, we apply the function, and we put everything in the new success. And just to be a bit more, there is another case where basically so here we can, let's do one fix right time. We can use a transform. But there is a problem that actually this is returning another outcome. So we are transforming our outcome to an outcome. So we did also another operation. But we can use the transform here because a user page is something that just do a simple operation. But for user fetcher, we need something that can transform basically kind of another transform. Just to say, let's say transform squared or something like that, where U is not a simple U, but is an outcome of U. So we want to do the same things, but where the function is a function that returns an outcome. So if it's a failure, we return the failure. That's not a problem. We don't want to call this function if the current result is a failure. If it's not a failure, we just call the function, which already have its own outcome, so we don't need to put in a success. So if we use this one, here we have an outcome of int, here we have an outcome of user, here we have an outcome of HTML. So here we have another transform, and this will be an outcome of HTML content. And finally, we needed to to recover. So at this point, just to check, we have an outcome of HTML content. What do we do if there is an error? If there is a failure, we need to return an HTML content at the end. So let's define a final function recover. Let's define as an external function from an outcome of the and the trick for recover is that we have an error, which in our case it's a string, and we need to transform this string in a t, so something like that. And if we have this string that can recover the error and give us our type, implementation is relatively straightforward, because we just needed to say, okay, if it's if this is a failure, we can apply our function. So in new function to the error. If it's a success, we can just get the value. So going back to our main, and here we can see that basically, if we have an error message, we just needed to create the content with some error and pass in the error message that we have.
Mm-hmm.
So yes, at the end, this is still HTML content, and if we run the code, we can still see everything. And if we put the funny user that doesn't exist, we got the nice error on it. And okay, I mean, we can finish to transform the rest of the application, but I think at this point it's more or less clear where we are going.
Yeah.
And this transform squared, usually I call it bind, but it can also be another, because it's binding two transformation together.
You see.
But so, let's see. Sorry, just saying, going back to the slides,
mm-hmm.
I wanted to some consideration of what we did basically. This idea of the error handling is a bit like the boarding gutter, because you have a chain of transformations, and if anything goes wrong, it goes in the error gutter and skip the other transformation. So this is the idea, and at the end you have this either is a D or there is an error, and of course you need this recover situation, the recover. And by the way, this is just a page of my book, just to put this error that we create is technically is a monad, because this is the transformation and this is the bind, but it's not really important to know, but just At the end, the monad is just a generic that can be transformed and combined, but it's just a definition. I mean, nothing to worry about. But yeah, happy to get consideration about this result. I also put a tweet about there are several libraries. Of course, you don't need to write your own. It's also nice, I mean, to write your own, but there are just ROKT is the most known and used, but it's such a very big library, so you can use that, of course. But if you don't want to, to import also other things, there are also some smaller specific library, like the one from Microball or the one from Result 4K. And well, for the reference, these are the results. Oh, there is also my own that is used by Ktor JSON that I bought, but it's not that. But going back now to the main point, I wanted just to give the main takeaway for me is this idea that functional programming is thinking on transformation or morphism, if you want it to be a fancy word. So rather than focusing on the data, we try to focus on the transformation. And this for me has been the moment that I think I start appreciating functional programming when looking at our application like a series of transformation. But of course, there are benefits. I mean, but I'm happy to discuss this stuff later. But just, I mean, like easier to test the simple function, easier to debug each one of which separately because they don't have a shared state. You have a much more compiled time safety. I mean, when stuff compile, you already have a reasonable amount of confidence. Everything being immutable is also easier to parallelize. The code tends to be less and more reusable because this small function is very easy to use in other place. Rather than object, they came with a lot of context, a lot of methods together. They are harder to reuse. But there are also problems with the functional approach. It can be harder, it takes time to get user to the style, and I definitely won't recommend if the team is not totally happy or some people don't appreciate. Some people love the first sight, some people don't. So it's totally reasonable. It's also there are some point where functional programming doesn't really work very well if you have a complex state management. I mean, if your state is very, very complex, like for example, you have a simulation or you have a UI, you can do with the functional programming, but it's probably much simpler to use of objects. Another place is when you really need speed and you need to mutate stuff in place rather than create a new object, immutable object. There are also the technique functional programming to do that, but probably imperative way is simpler and more natural. And it's great with Kotlin that you can use both. So I'm definitely not saying that you need to use functional programming anywhere. And also the tooling kind of a level of abstraction. So that I think that is it's really great for that kind of task where you have like a web server that we saw. I mean, we take a an HTTP request and we transform in HTTP response, or ETL. We take something from Kafka queue and we put another store, stuff like that. This kind of application where everything is a flow. Functional programming is very good fit, and I mean everything is small function for me is it's fun, it's great, and it's a great win. But it's not for everything. Is not for everybody. But happy to get a question. Sorry if I did a bit rush
Yeah.
on the end.
Well, we have some nice comments about it all, like about the final result that people think it's more readable. Well, maybe it's a matter of preference, but it's more readable to me as well, and I'm not a big guru in functional programming. So I think we had like one nice general question that we can quickly discuss here.
Yeah.
Is that when you kind of transform the application logic into this way, you start introducing more functions, and then for some people it would be like a big question: how do you keep the discipline, and how do you keep the project structured? Like, how do you, if the project grows?
Yeah. No, it's okay. Now I put everything here. It's clearly you need to handle packages like in a normal project. Things tends to become. I mean, this was a sorry, not this one. Um, yeah. Sorry. Yeah. So this was the file with the SSS database, and it will still be a file with the SSS database, but without having the class anymore, and instead of having a bunch of function.
Hmm.
And it's not that hard to handle after a while. The advantage of using pure function is that each one does something very specific, and it's you find that to reuse the same function multiple times, and maybe if this was a database, a data access layer, it's kind of heavier to reuse because maybe have 10 methods and you need only one, but if there are smaller functions, you can just reuse the one that you need.
I see. Well, yeah, like it was a heated discussion and a lot of comments, like in general
Yeah,
about the approaches, and there weren't so many questions, but I see that people are opinionated about this topic, and I hope we'll have more sessions on functional programming with Kotlin in the future. And
yeah,
well, we are way over time today. Thanks everybody for coming, and thanks Alberto for sharing your wisdom. I hope to see you in some
yeah,
events in the future, and maybe on this channel as well.
definitely.
With that, I think we can wrap it up here, and thanks again, and have a nice Kotlin, everybody.
Thank you very much.